So this session will be about Docker networking and going over the absolute basics. Covering off a couple different ways to send packets from containers, how they work with the host that's running the Docker daemon, different things like that. So this session will kind of continue on from a previous session that we had about the basics of how Docker handles isolations for containers using namespacing. And in previous session, we used commands that invoke namespacing, such as unshare, to show how we do file system mounts and network isolation from a networking stack perspective. So we're going to continue on from that and take that perspective and use it from a networking standpoint. So just going to wait a couple more minutes for everyone to get connected. So just bear with me here. While we're waiting, I'll just kind of talk about the screen that I have set up. So I've got 3 terminal prompts. The top left and top right I'll be using to enter into a container to run bash, execute different commands. The bottom terminal window is for interacting with the host that's running the Docker daemon. So use that to flip back and forth a little bit. If you're tuned in via Twitch and logged into the chat, feel free to drop any questions into the chat window, or even just to say hi, give a shout. So give it a couple more minutes for everyone to connect. Right, okay, so let's go ahead and get started. Let me just arrange my windows a little bit here. Right, okay, all right, so let's get going. The first thing I want to do is a kind of quick recap of last week. So we used namespacing in order to isolate different resources for containers that we run. And so it's just a quick question. Considering what we learned in the last session around providing file system mounts into a container and using namespaces to set different folders as root. If you can drop an answer into the Slack for this question, so are we able to use different Linux distributions on top of each other? So if we were running, for instance, say Ubuntu as our Docker host, can we run CentOS as a container on top of that? Put in the answer into the chat window, but more importantly, let me know your thinking behind that answer, as in what allows us to do that. So I'll give it a couple minutes. Okay. So we got some answers coming in saying, yep, we can run different distributions. So just to clarify why that is, so within Linux, you have the Linux kernel, and people who make distributions take the kernel and they package it along with a set of binaries and related files in order to run programs on top of that kernel. So essentially, in a basic way, all a Linux system, a Linux distribution is a collection of files. And so we know that within, from the last session that we did, that we're able to provide a file system now into a container. So essentially, we're able to run different distributions. So on my machine here, I've got Photon OS, and I'm going to run Ubuntu. Actually, sorry, I'll run CentOS because Photon OS is essentially stemming from Ubuntu. So all the files that are here are is the file system that's provided by the overlay FS that is pulled down through the container image. So these aren't the files from my Photon OS operating system. So hence we're able to run different distributions on top of other distributions. So that was just a quick, kind of a quick reminder from last session. Also, the other thing is that we have the unshare command to help use a command line interface for creating namespace for different resources. So just a reminder, file system mounts, user UTS namespacing, interprocess communication namespacing, network, PID, user, cgroup, etc. So we could even do unshare -n, bin bash, and whatever network stacks that we set up here will be isolated from the host, the Docker host. So this is important for today's session as we kind of go through the different types of ways of handling the networking. So let me exit out of here. Let's get started. So the first thing that we want to do is take a look at the different ways that we can interact with networking from a Docker perspective. For those who have a Linux machine, who are following from home, if you're using Photon OS, we'll be using some ping commands. So you want to use tdnf install iputils. We'll give you the ping command. And if Docker isn't already started, the Docker daemon that is, you can just go ahead and start Docker. So mine's already going, so no problem with that. First thing that we want to do is take a look at the capabilities in terms of what can be run on top of Docker for networking. So if we do Docker info, I'll scroll up. And here we have our plugins. So the default installation of Docker has libnetwork, which allows for different drivers to be used. So these are the ones that are available to us at this point in time. Other people, open source projects, provide additional drivers that can be used along with Docker, but these are the ones by default. So we're going to go over a couple of these, such as the bridge, Mac VLAN, and overlay. So we'll start with the bridge first. All right. So there's a couple different things. So Docker heavily utilizes existing applications that are available in most Linux distributions, things like IP tables, etc. So we're going to take a look at how they interact. So for instance, come down here, IP tables -L, and IP tables is the network policy that runs on a Linux machine. So you can handle things like accepting packets, dropping packets, forwarding packets, doing all that sort of stuff. And when you install Docker, it installs a number of rule sets within the IP tables. And right now we're not running any containers, so this is kind of fairly boring. I wouldn't worry too much about all the details around this space. But if we run a container and specify a port, so so we're going to make this interactive. We're going to use P to specify a port, 9000. So this will map port 9000 on the Docker host to port 9000 within the container OS. We're going to specify our container image, and we're just going to go to the bash prompt. Okay. So we're just going to leave this running here, and we're going to rerun this IP tables command. So now you'll see that we have an update here within the chain Docker. We now have a destination, 172.17.0.2. And we're just going to use a couple commands here to explore this space a little bit. First, let's see what we've gotten here. If we take a look at the interface within the container itself, we have 172.17.0.2. So this is an entirely different network than what I've actually got on my Docker host. So if we scroll up, so F0 is the NIC that's attached to my physical network, and we have 192.168.20.9/24. And so what I'm using here is, for this first container image, is the default networking, which is a bridge connection. So within Linux, we have a way to bridge interfaces together. So if you kind of cast for those familiar with internet connection sharing for Windows, or for those with Linux bridging, where they wanted to provide a machine to bridge a connection to the internet to another machine, you could specify that two network interfaces are able to communicate to one another on the same network. So for Linux, we have our bridge CTL command, which is how we can interact with the bridge on the operating system. So if we take btr CTL show, we have a couple different bridges here. So the one that's more interesting to us is the Docker 01. So if I do btr CTL show Docker 0, we get some information there, but let's do this one instead. Okay, so we get the interfaces here. So we have an interface attached to the bridge, and for the for Linux, I guess this may be better to back up a little bit. So for networking, you can create virtual Ethernet interfaces. I think I already have some here because I have a container running. So I have a virtual Ethernet interface, and when you create one of these, you give it a peer. And so why this is important here is that I have a virtual Ethernet interface on the Linux host, and I've created a peer, and the peer is assigned through the namespacing to the Docker container. So essentially, by using virtual Ethernet interfaces and the Linux bridge, I'm able to provide the network connectivity from my container image out to, effectively in this case, the internet. So the other thing that we can do is Docker has its own network commands that you can use to interact with. So if I go Docker network ls, I see the different networks that are available and the associated drivers. So we can do Docker network inspect. Do this one. So we'll get a JSON response back and telling us the information about our bridge, such as the ID, when it was created, the scope, which is local. Local means to this Docker host, what the driver is, in this case bridge, IPAM, so this is for allocating IP addresses. In this case, it's configured with a subnet 172.17.0.0/16 with the gateway of .1. So you see, one obviously is occupied, so this is the first machine that'll run, so it's given it .2, you'll see up here. Following on, we can see what containers are available. So here we have a particular container, which is the one that's running up here. We have its human sort of readable name, and then we also have some information about the machine. So the MAC address here, which you'll see corresponds to the MAC address up here, as well as the IP address corresponds as well. And then we have some other metadata about the network bridge. So one thing interesting here is true, meaning that it's the default bridge. So when we just ran our Docker command, we didn't specify a particular network to use. It just used the default, which is this one. And then you can see effectively the bridge name is Docker 0, just as we saw with the bctrl show command. So let's exit out here. Okay. Any questions regarding the use of the bridge or the virtual Ethernet interface or anything that we covered so far? Just put your questions into the chat. So to kind of illustrate the pairing of virtual Ethernet interfaces, we'll just create one. So here, I'll do it in this main window here. So we can do IP link add. We'll give it a name for the interface. We're going to tell it it's a virtual Ethernet interface that we want to create. Because they're created in pairs, we need to specify a peer, and we'll just give it a name for the peer. So if we look at our networking stack again, we can see the interface here, the vPeer at veth-a. Now the reason why we can see the both sides for the pair is because we've not used any namespacing. So the important thing to understand, so for namespacing for the network, is that if you isolate a network via namespace, you're going to see it removed from effectively a host. So if we namespace a part of the pair to a container, it means my host won't see that anymore. So you see up here, we've got pairs here, but you don't see the other side of the pair because that's namespaced off. Hopefully that makes sense. Let me just clean up after myself. So IP. Oops. Okay, so got rid of that. The other thing is that because by default we use a bridge, it means that we can pass traffic from one container to another, even though we may have only specified a published port. So what I mean by that is, for instance, like if we do docker run and do something similar over here. Okay. So if we go to our host and do this .ps, we can see we've got two containers running. One is publishing port 9002, and the other one is publishing port 9001. So if we go and show some interfaces here. Yeah, okay, so this image doesn't have this image doesn't have the commands to be able to look at the interfaces. So let's try this space out here and do this one as okay. So we can see our IP address is 172.17.0.3. Let's see what happens. Can we ping that? Yes. Can we ping it from here? Yes. So so we can see that even though IP tables has set up ports to be able to accept these connections to these specific machines, we can still handle communication to the different machines because we're using the network bridge. So it's important to remind yourselves that you may not have as much network isolation as you think you may do by default. It's good to be aware that this bridging construct is being used. So let me exit out of here. The other thing that I wanted to note is that Docker handles DNS. So depending upon the driver that you use, bridge in this case, or overlay in another, Docker will use different methods for providing DNS. So for a bridged network, so Docker run let's see. Part of the files that gets mounted in the container image, or when you run the container dynamically, is the some files such as hosts. So in here, we've got some entries here. Obviously, when somebody created their container image, they didn't put this file in there. And this is something that's created at runtime when you run the container. In a similar manner, resolve.conf. Oops. We see we have the name server here, 192.168.20, which is actually the DNS. So if I do etc. resolve, cool. You'll see actually it's pulling that from the exact same file. So the container is using the same DNS server that my own host operating system is running. It also mounts another file for the host name. Oops. Okay, so that pretty much wraps up I guess, the fundamentals for Docker bridges. So the next thing that we want to do is go over and talk about the other types of drivers that we can use. So the next one would be talking about the Docker overlay network. So one of the, I guess, the primary drawbacks from the Docker bridge is that the way that it's configured is host only, meaning that you don't provide a seamless network across multiple hosts. If you're using the bridge networking on multiple hosts, each one would be a separate instance. And those wouldn't necessarily be able to communicate to each other on the IP address that we got. So for instance, you may remember we have an IP address assigned here, that 172.17.0.2. If you ran this container on another host, and both running simultaneously, say for instance maybe the other one got 172.17.0.3, they wouldn't be able to communicate to each other. They're effectively isolated. So one of the things that people like to do is to be able to run containers across multiple hosts and have them talk to each other. So maybe a web server on this host and a database server on another host, an application server on another host. So you need a way to kind of bring that together. So for Docker, you can enable Swarm to be able to provide some capabilities for these machines. So I've already run it, but you can do Docker Swarm init to start the swarm. So this would be the one that you run init on, be your master, and then you'll get some information in order to join the other machines to the swarm. They then use a distributed data store in order to hold information about what's located on top of the networks that you create, and keep everything in sync that way. And finally, one of the things that they use is VXLAN for packet encapsulation, so that you can be able to create a interface on the Linux host. When packets from the container hit that interface, it gets encapsulated and then sent across the physical network. And then when it gets to the corresponding other Docker host in the swarm, it's de-encapsulated and the packet gets sent on to the target container. So let's have take a look at how we can use networking. So a couple different ways. We're going to do things by hand. If you're using Docker Compose, you can create a single file and specify network information in that file, but we're just going to use some of the command line things. So as you saw before, let's get out here. We used a Docker network command. So we can do different things. We can take a look, see what's available. We can create networks. We can delete them. Different things like that. So we'll create one as an overlay. So we'll do Docker network. Create. We're going to give it some flags. So attachable just means that I'm able to attach some containers to it on the fly. -d is so I can specify the driver that I want, and in this case it's going to be overlay, and then I'm going to give it a name, overlay net. So it just returns me the ID of the network that I created to confirm that I was successful. So if I do Docker network ls, I can now see that I have my overlay net, which is the one down here at the bottom. Important to note the scope. So for instance, the bridge network that we looked at earlier, scope is local. And in this case, the network that we created is the scope is the swarm. So all the nodes within the swarm would be able to interact with this network and process networking from one container to another via the same network subnet. So let's take a look at this new network that we created. And we have some information about it. Not going to be a whole lot right now, just some information such as like IPAM. So I didn't really specify any details. So there's no IPAM set up. Only thing I did do is set as attachable as true. And that's pretty much it. So it's a pretty boring network from our perspective. But just to show you basics of how we can attach to that network, so we'll run a command to create a Docker container, and we'll specify the network that we want to attach to, and we call ours overlay network, and we'll give ours a name equal test1 nginx. And on this one, we'll do something similar. So Docker run net. This one will also be in Unix. Okay. So now, if we go and take a look at that network again, I'll see that I've actually got two containers associated. We have one container with the name test2, another one test1, and they've been given some IP addresses to work with. So because there wasn't anything there, we got set up some default information, so we're just going to use 10.0.0.0 and work with that. So these machines can ping each other, and if they were on separate hosts, we could still ping each other using the 10.0.0.x address. So the other thing is that we can see our peers. So this is the Docker host. Right now, I've only got a single host in the swarm, but if we had other ones, then we would see the name and corresponding IP information in here as well. Okay, so any questions so far on some of the topics that we discussed, such as the bridge driver and the overlay driver? I'll pause for a moment. Okay, right. So let's move along. So this is obviously great for handling traffic from different container hosts. But one of the issues is that you have to use net in order to communicate with things externally to the network. So if I run two containers on two separate hosts, they can communicate to each other with their internal IP address, but if you want to have this container contact some other physical machine, then the address has to be translated. Another approach is to use kind of a, I guess, a more physical way of doing things. So within Linux, we can create network interfaces as a sub-interface off of an existing one. Then we can go ahead and bridge these interfaces into containers, so that we give them a corresponding IP address that actually sits on the physical network. So this means that we don't have to use NAT for the container that we're running. We can just communicate directly. So let's take a look at a couple different things that we can do here. First thing I want to note is that there's kind of two ways to set this up. One is using the bridge, like we've seen before. The other one is that you can set up with a 802.1 queue, and you can set up a trunk there, and you can use layer 3 or layer 2 to handle that traffic. So I'm going to show an example here, and this is just going to be using the bridge networking. So if we take a look here, let's see what we've got. So we're going to go and create a network now. So network create -d. So this is specifying the VLAN, the Mac VLAN driver. So you may recall earlier when we did our Docker info, we had different network drivers that we could use, and so this is one of them. And so let's go ahead and specify a subnet, and we're going to use my physical one, 0/24, and specify the gateway as the gateway that already exists. Oops. Give it an IP range for the IPAM stuff to work with. Give it limited range. And tell it which NIC to bind to. So as I mentioned previously, we can have interfaces and sub-interfaces. And we're going to then give this a name. So I've got my ID returned back, so network ls, and we see that I now have my Mac VLAN. So this is local because I'm just creating sub-interfaces off of the existing interface, in this case F0. No other host will be aware of this, but it doesn't matter because we're giving a physical IP address to the container so they can talk to anywhere. So the next thing that we can do is to attach a container to this. So if I do docker run -it, tell it to use my network that I just created, specify the container image that I want to use, and tell it what. If I can actually specify exclusion lists. So when I created this network, oops, what's going on here? I think something's taken the focus from my machine. Bear with me here. I think we have a fusion issue. So I think what's happened is I've got an IP address conflict which is preventing me from connecting to this terminal. I'm just going to take a moment to connect to the local console and just kill that container, so just bear with me here. Okay. So I could actually create that network and specify IP addresses to exclude. If you're doing that for your own, you can just take a look on the Docker documentation on how to do that, and that will walk you through the process. So there's some good things and some bad things. Because you're putting these sub Ethernet interfaces on the network, and with Docker, people use it kind of in high volume ways, so creating lots of containers, bringing them up and down all the time, creating, deleting, all that sort of stuff. So you need to be aware of kind of how many MAC addresses are going to be on that particular VLAN. or for the host, what is the max number of MAC addresses that it can allocate, different things like that. So there are some disadvantages or things to be aware of when using this, but the plus side is that you don't have to do network address translation for the container that you want to run. So that's kind of the quick 360 for Docker networking basics. The more complex networking starts to come into the picture when you use different container orchestrators. So for instance, like with the overlay networking, we had to enable Swarm. There are other orchestrators, such as like Kubernetes, for instance, that will handle the networking in a certain manner, things like that. So as for the basics of container networking, that's where we're going to leave it for today's session. I'll pause for any questions, and if there's no questions, then we'll just wrap up for today. The next session will be the last session of this particular program. So, well, let me preface this. So in 2 weeks' time, we'll have a programming session. And then 2 weeks after that, we'll have the final CNA session. So in that session, we'll be looking at the fundamentals of Kubernetes to show how we can use container execution and bringing some of these things that we talked about regarding namespacing into the orchestration side. So I'll just pause for a moment to take any final questions for today's session. Okay, so that looks to be about it for today. If there's any questions at all, please just drop me a line. I'm happy to answer anything. And like I said, in 2 weeks' time, we'll reconvene to go over programming and scripting elements. And then 2 weeks after that, we'll have the final CNA session, where we'll cover container orchestration, things like that. So thanks, everyone, for tuning in today. Appreciate it, and catch you next time.